The replication lag monitoring subsystem tracks the temporal distance between write acknowledgement on the primary node and confirmation of that same write on replica nodes. Lag is measured in milliseconds and calculated as the difference between the primary's commit timestamp and the replica's last applied transaction timestamp. This measurement occurs continuously through heartbeat frames exchanged at 5-second intervals. The system maintains separate lag counters for each replica connection to enable per-node diagnostic analysis. Lag thresholds are configured via the replication configuration file using the lag alert threshold MS parameter. The default value is 5000 milliseconds. When observed lag exceeds this threshold, the monitoring system generates an informational event log entry with severity level warn. No automated remediation is performed at threshold breach. The threshold applies uniformly to all replicas unless node-specific overrides are declared in the per-replica threshold section of the configuration. The lag measurement algorithm operates in the heartbeat processing thread without blocking the primary's write path. Each heartbeat from a replica includes the replica's current applied transaction ID and apply timestamp. The primary node maintains a mapping of transaction identifiers to their commit timestamps in an in-memory transaction log buffer. Lag is computed by lookup of the incoming transaction identifier followed by subtraction of the replica's timestamp from the primary's recorded timestamp. Lag measurements are aggregated into a circular buffer of fixed size. The buffer size parameter defaults to 1440, representing 1 entry per minute over a 24-hour period. Once the buffer reaches capacity, new entries overwrite the oldest entries in round-robin fashion. Aggregate statistics are computed from this buffer: the mean lag, the 95th percentile lag, and the maximum lag observed within the retention window. These aggregates update every 60 seconds. The lag statistics are exposed via the metrics endpoint at the path/metrics/replication/lag. The response format is JSON and includes the timestamp of the last update, the lag value for each named replica, and the aggregate statistics. The metric replication lag percentile 95 ms reflects the 95th percentile of measurements within the retention window. All values are reported in milliseconds as floating point numbers with millisecond precision. When a replica connection drops, lag measurement for that replica ceases immediately. The replica's lag value in active metrics is marked with a status field indicating disconnected. Historical aggregate statistics are not retroactively recalculated. Upon reconnection, the first heartbeat from the replica is processed normally, and lag measurement resumes. Any gap period is not represented in the aggregate buffer. The heartbeat frame structure includes a protocol version field, the replica's node identifier, the last applied transaction identifier, the replica's local timestamp at heartbeat generation, and a sequence number. The sequence number increments with each heartbeat and is used to detect missed frames. If the sequence delta exceeds 1, the monitoring system logs a diagnostic warning indicating potential network issues on that replica connection. Clock skew between the primary and replica nodes is handled through a skew correction factor. If a replica's heartbeat timestamp is detected to be earlier than the previous heartbeat's timestamp by more than 100 milliseconds, the monitoring system assumes clock drift and applies a linear correction to subsequent lag calculations for that replica. The correction factor persists until the replica's clock realigns within the 100 millisecond tolerance. Event log entries for lag threshold breaches include the following fields: timestamp of detection, replica node identifier, measured lag in milliseconds, configured threshold value, and a contextual message. The event level is warn. These entries are written to the standard event log with a source field set to replication monitor. Event log retention follows the normal event log lifecycle and is not specific to lag monitoring. Per replica lag threshold overrides are declared in the configuration file under replication.perReplica thresholds as a mapping of replica node identifiers to threshold values in milliseconds. If a replica identifier in this section does not match an active connection, the override is logged as a configuration warning at startup, but does not prevent the system from starting. Overrides take precedence over the default global threshold for the specified replica. The lag monitoring subsystem does not perform automatic failover or replica promotion based on lag thresholds. Breach of a lag threshold is informational only. Operators must interpret the metrics and make remediation decisions manually. The system provides the lag data. External orchestration tools or operator intervention determine the response. This separation of concerns allows for application-specific policy decisions without embedding them in the core replication mechanism. Lag measurements may temporarily spike when the primary experiences a sustained write burst. During high write throughput, replicas may accumulate a backlog of transaction log entries to apply. Lag returns to baseline once the write rate normalizes and replicas complete their backlog processing. Short-term spikes above the configured threshold do not necessarily indicate a problem and should be interpreted within the context of primary write load. The aggregate statistics in the circular buffer are computed lazily upon request to the metrics endpoint rather than continuously. This design reduces CPU overhead during normal operation. If no metrics request is made within a 60-second interval, the aggregates are not recalculated. Upon the next request, they reflect the full window of data regardless of the time since the last calculation. Replica identifiers in the monitoring subsystem are derived from the replica's configured node name in the cluster topology file. If a replica's node name is changed, the lag history associated with the old identifier is abandoned, and a new history begins under the new identifier. This behavior is intentional and prevents confusion from identifier aliases. The old historical data remains in the circular buffer, but is not correlated with the renamed replica. The metrics endpoint supports a query parameter named window minutes to retrieve aggregate statistics for a custom retention window. Valid values range from 1 to 1440. If the requested window exceeds available historical data, the aggregates are computed from all available data. A window minutes value of 0 returns current instantaneous lag values, only without aggregation. The replication lag monitoring subsystem is initialized at startup as part of the replication module's bootstrap sequence. If the configuration file is invalid or missing required parameters, the system defaults to threshold of 5000 milliseconds and buffer size of 1440. Initialization logs are written to the startup event log. The monitoring thread begins operation after all replica connections are established or after a 10-second timeout, whichever occurs first.